Just let me know when you want to start. Just go ahead, just give me the word.
1 second.
1 second.
Talk now.
Talk now.
That's better.
That's better.
Okay, you're live.
Live?
Live.
3, 2, 1, live.
3, 2, 1.
How's everybody doing? Hope y'all are having, it's warmed up here finally, and but it is overcast, so it's not as, you don't have the sun on you at least. But we were cool here for a little while in Knox Vegas. So it's been kind of interesting for this late in the year to be this cool, especially in the evenings. It's been nice though, good for sleeping. So so we got a nice day again here in Knox Vegas. This is part 2 of the 9S meter site that we're testing. It's an overhead 9S site, and this is the second part, and so we'll be talking about that here in a second. Today, as I said, part 2. Next week will be part 3. JP and I are going to pre-record that today because I'll be up in the Northeast, and then for
Are you kidding?
He jumped on that one. I almost wrote it on a piece of paper, you know. I like to play games like this. I was going to write on a piece of paper. I was going to write, "You're going to jump all over this." And I was going to hold it down because I asked JP, I said, "Hey, I was just kind of thinking, man, maybe how about if we, you know, since it is Memorial Day week," I didn't even finish. And he goes, "Sounds good to me." So, yeah, we've worked together too long now.
I got that calendar wrong. It's actually June 1st, isn't it?
You got me, brother. Yeah, it is. It is June 1st. Yeah, because June 2nd, I'm driving up to Nicholasville. Yeah, so yeah, that's right. It is. So it would be June 1st is Memorial Day. So
May 31st is Memorial Day.
I'm sorry, May 31st. So we're not doing a webinar on June 1st. Yeah. Okay. Anyway.
Clear as mud.
Clear as mud. So June 1st, no webinar. Memorial Day. And then so then the following week we will do part 3. No, we'll do part 1. Oh, hey!
Yeah.
Let's everybody, why don't y'all send in something to us so that we'll send in something for the next one. So we got a little time now. And this is what we'll do. Off of your votes, send something out on this, JP, and we're asking for your votes on what meter form, and you need to also designate on there pad mount or overhead. So which meter form, pad mount or overhead we do next. We've got the 9S pad mount left, then we've got a 3, a 4, a 5, and a 6, both overhead and pad mount. So you got 8 choices, 9 choices. So so pick the next one, and we'll go by your votes. Whatever you guys vote the most on, that's what we'll do. Cool. Okay, we're going to go over hooking up to the meter, pre-test checks and analysis, running the meter test, and then interpreting the results. So the second part of it is where we're going to finish up checking things out, doing the pre-test checks with using the machine to look at things before we actually start running the test, and then we will go through the actual meter test of it. Then we will finish it up on the next one where we'll do the CTs and then assess everything that we found there. Okay, so that looks like that's going to be the rest of it. And then please send in your votes so we can decide which meter form and whether it's going to be overhead or pad mount is the next one that we do, which will be the week after Memorial Day. So that would be June 8th or June 9th, something like that. Okay, cool. So so please let us know about that. I just wanted to say we're so appreciative of the time that we had to do this, the unbelievable opportunity we had to do this, but also the feedback we've been getting. It's been really something, the feedback we've been getting about this. So so we're happy that you guys are getting something out of it. It was a lot of fun to do because when you consider that you might help somebody be a little bit safer getting back home, it makes it all worth it. So the alligators and the bugs and the gunfire, all of it's worth it. So so anyway, so before we get rolling, I'm going to pray here real quick, and then we'll get started. Thanks. Father, thank you so much for another wonderful day. I just hope, Father, that I don't just get too complacent or unappreciative of what you've given me. It's just incredible to think that you've actually adopted me as your child, to think that I'm a child of the one true God is just amazing. And my brother Jesus Christ is sitting with you now up there, having risen from the dead, and so He's left the Holy Spirit to help me. And Father, that's what I want to tune into today is I don't do it nearly enough, is asking the Holy Spirit to guide my words and guide my actions today so that I will be a witness to you. And if someone asks, that way I can tell them what I believe. So thank you so much for the Holy Spirit, because if your Son hadn't died on that cross, then He wouldn't have left the Holy Spirit for all of us. So He died for every single one of us, Lord, and just thank you so much for that. So all of these things I ask and say, according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Cool. So a quick little review of where we're at on this site. We've done the pre-check. We noticed there was some washout around the base of the pole. We noticed there was some arcing in the can when Brylan cracked it open and looked in there. There was some arcing back there. And now we're actually getting to the part where we're actually making the connections and hooking it up. So you do a pre-check. You look over that pole. You check those transformers out. You check what service type it is. You don't believe the paperwork or anything. And then you also do a pre-check of check the pole out. Make sure, in this case, there was some washout down there. We also noticed arcing on the back of the can where there we could see that something had arced back there. So now our spidey senses are up, so to speak. We noticed a difference in the test switch, so we think the test switch probably got changed out, whatever they did after that arcing was there on the back of that can. And but up top, didn't notice anything super bad on anything. We did make a note of a few things, but by and large, all the things that you might find there, nothing super unusual. But we all of those things we did make a note of. These are things that if you've been out there a lot, you've seen this stuff out there. So now we're moving actually into the testing part of it. So we'll just pick it up right there. And looking at this, they may have even changed out the test switch.
Right, yes.
Yeah, because this does look like a little different test switch than we've seen previously. So they may have even changed out the test switch because of something that happened in the past. Nice catch on that. I hadn't seen when you opened her up. So. So notice here how. Okay, so you heard me talk about this earlier on other webinars, but I'm going to mention it every time, right? Because this might be the only one you watch for a while. So you notice here, this is a great shot, man. I can't believe how clear all this stuff is. Great shot of the test switch here. There was arcing right back over here. So that's where we saw the arcing was over just to the left of the test switch. So this was different than the other test switches we had seen. So I would guess they had changed it out. Here's where we talked about you may not have everything marked and color-coded for you, right? So you don't have between your A and B's, we're just black and reds. Reds here are my voltages. They would be the long stroke blade, and I don't have a place to insert like you see here for a duckbill. So these are my voltages, A, B, C, and neutral. You notice he connected neutral up first. He goes in with, uses all of the teeth on the alligator clip, coins those surfaces a little bit by working them back and forth, right? So you attach the neutral first to give himself a safe path in case something got wrong. It would have a safe path to neutral on the ground here. So for safety's sake, always connect your neutral up first. Then you notice here, when he makes these connections, I had mentioned I turn the handle to the right. And if you're going to put these on first, you definitely want to have the handle turned to the right. And why is that? Because my short stroke blade, if you have the test switch we have here at the bench isn't this way, but if you have your shunt and your returns together for the currents on the CTs, it's almost always is going to be the shunt to the left and the return to the right. So the reason why you turn that alligator clip with the handle over here, that's your short stroke blade. Remember I've said to lean it down just a little bit so the short stroke blade won't hit. It won't go all the way down and hit it there. If I did it the other way and turned them to the left, what would happen? It'd be on the left. My long throw, which would be my return blade, would want to hit that handle and knock my alligator clips off. Okay, so if you're going to put your alligator clips on first, go ahead and put them, this is the way I do it now. You can do it any way you want. Every man for himself. I get on the blades, coin them a little bit, work it back and forth, and I have these always to the right, so my short stroke blade is on that side of it and it doesn't knock them off. If you put them on afterwards, you don't have to worry about that, right? but most folks are going to put that on to get that neutral connection, okay? So they can, for safety's sake, so they're going to put their alligator clips on first. So just wanted to go over that. So here are, this would be the return. Remember, you see that piece of metal goes across there. That's the short stroke blade. That's my return blade for A. Golly, sorry. That's my shunt blade for A, my return blade for A. The long is the return blade where it's coming back down from the meter. So it goes out of here, goes up into the meter, comes back through the meter, and comes back down here and goes back out to the CT, okay, to the return. So it goes in and out. So as it's coming down here, if I put my alligator clip, my duckbill up, it's going white. So it comes down, hits the white, and it's always in the white, out the black. So it'll go in the white, come in through my duckbill, and go back to the kit, and then back out the black, in the white, out the black, the return to here, and goes back down and return to the CT. So I'm going to open this up and open this up to insert that duckbill. Then I close my shunt back in. When I close my shunt back in, I've completed the circuit. So now all I'm doing is I've stuck that duckbill in there so I can take a peek at, and I'm in series with that current that the meter's seeing. So I'm looking at the same current the meter's seeing with that duckbill. So it's just got to flow in and out. Okay? Thanks, JP. He gets on his blades because he gets more contact with that alligator clip. Sometimes you can lose the ends of the teeth off the end of them to grab onto the end of the tabs. I know a lot of guys like to put them on the end of the tabs and let those teeth, because there's usually teeth on the end of these alligator clips, right? And they'll tend to grab those teeth right in the end of that tab, that hole in that tab, and they want to grab onto that. But Brylan, since he's done so much out in the field, his general practices is he likes to grab onto that whole blade to get more contact. And notice how he works it a little bit, and he's just gotten in the habit. And we talk about getting in good habits out here in the field, and he's just gotten in the good habit of always just giving it back and forth a couple of times to break through any corrosion or anything. Now this is a newer test switch than what we've seen here in the past couple of days, but it doesn't matter. Just get those general good practices and good habits in your head of sliding her back and forth a couple of times and getting you some good contact with those alligators. And then also, you'll notice he did the same thing with his duck bills. I mean, because the corrosion can get in there as well. So he worked those a little bit. So he can work those two surfaces against one another and knock that corrosion off there and make some good contact.
I'm gonna go ahead
You
and
noticed
pull the
as he
power
was
out
putting
to
them in
see-
there, he moved them out of the way a little bit. He made sure, and he made the long swing of those returns get by those alligator clips. So he actually demonstrated what I just talked about, letting them swing by, and they swung by on that short side over here. So when they swung by on that short side, they didn't knock that alligator clip off.
phase right here on this Landis gear meter. Need to cycle the power before you're going to be able to get your pulse.
That's right. Landis gear meters, and when they are first actuated and first have power go to them, they emit pulses for a time, but then Landis gear meters, the pulses will stop, okay? So if you're going out there and that meter's been out there for a long time, you will need to open one of those potentials up and get you, and break that power for just a second and put it back on so that you can get the pulses to start being emitted out of this hog nose or COM port, all right? If you think about it, if you put it in a test board, the same thing happens, right? You put it in a test board, it gets powered up, then it will emit pulses. But we're out here in the field, so if it's been sitting there a long time, chances are it's not emitting pulses anymore. And we don't want you standing there going, man, where in the heck are my pulses? And start thinking there's something wrong with either equipment or the pickup or something like that. So for the Landis gears, you will want to go ahead and actuate that. Okay. So you remember we talk about that Rolodex in your head, the things that you think. And that's one of the things you can add to your Rolodex, right? If you're testing Landis gear meters, you're not going to get a pulse until you cycle that power, until it sees, it gets re-energized. And when it gets re-energized, it starts emitting pulses out of the COM port or hog nose on there, okay? But until that, it's not coming out of there. So if it's sitting there, it's been sitting there a long time, you're not getting any pulses out of there, okay? So that's just another reason. You say, let me look, is it a Landis gear meter? Oops, I need to open up my voltage. Do I have my pickup? Is my pickup screwed in on the back of the test kit right here? Is it in test mode when if it's not in test mode, it's supposed to be in test mode. I need to get it in test mode. The simple things first. Why am I not getting a pulse? And then it could get to the point where you've got something cross-phased and you're canceling everything out and you're getting almost no watts out of the thing. Well, then if you don't get any watts, you're not getting any pulses, right? So it could be something as complicated as that, but you start out with the simple stuff, okay? Thanks, bud. So what do our vectors look like?
Right here we're looking at the vector screen. I come over here and press the vector button on the hotkeys, and on this particular site, like I said, it's 277/480. So we're looking at all our voltages down through here are looking pretty good.
Okay. So you've heard us mention this before. He's doing a great job in that before you get rolling on a test, hit your hot buttons over there and see what you've got going, because you have more buttons and tabs down here at the bottom. You can see all those tabs available at the bottom of the screen. Once you start into a test, those aren't available. You also, once you start into a test, you can't stop and save the stuff off the hot buttons, okay? So, turn my phone off here. Sorry about that. So, until you go into, once you go into the test mode, you don't have those options at the bottom. You don't have those different tabs at the bottom because you're in the test now. You also don't have the capability of stopping and saving. Okay, that all happens pre-test. So that's why you need to go ahead and that's why.
Nobody else could see that box, just you.
Oh, really? Oh, okay. They're all going, man, okay, he's off his meds again. Sorry, anyway, there's a great big box here in my way that you couldn't see. Okay, so all of these are available pre-test, right? Also, as I was saying, if you saw something funky on those hot screens, any one of these hot buttons that you hit, let's say you hit the waveform and it showed some really choppy waveforms, which are indicative of harmonics, the buttons at the bottom pre-test are you can hit stop and it'll take a snapshot of that and then hit save. And when you hit stop and save, it just adds that to the report. So you could add a waveform shot, you could have vectors, you could add that table that's got all the information on it, you could even add the harmonics in a bar graph form. But any of those pre-test, you can hit stop and save. Once you're in the test, you can't. That's why it's so important to look at things pre-test. And we'll talk, I'll stop it here in a second, but he looks at something that's really important here. Go ahead.
Can't complain with those. And secondary current looks great. We're looking at about 2.2.
So you notice it's 277/480, right? So we're looking at the secondary side. So we should be looking for around 277 here. So we see that. We also notice our current is 22, 21, 22. That's good for us for testing, right? We know that we've got enough secondary current to test with. If we start getting below a half an amp on secondary current, we know we're starting to get in having trouble testing. So these numbers look great for testing. I mean, we've got the voltages look pretty close. I've got a nice amount on there. ABC rotation here at the bottom, talked about it a little bit, but just to make sure we cover it. ABC rotation, right? If these two were swapped, then that would be CBA rotation. Remember, I got thrown to the wolves early on in this thing, so in my head, I thought it should have been CBA rotation, right, if it goes the other way around. But it doesn't. It actually goes CBA rotation is just if you, A is always going to be my reference, always going to be right there at 0. So it's if the other two are swapped, then you would call that a CBA rotation, okay? So this is ABC rotation. I don't see anything super crazy right here, but we're going to talk about it here in a minute. There's something I don't really like right now. But as far as being able to test, it looks like I don't see anything crazy voltage-wise, and I know I've got enough load on my secondary side. I'm going to be able to test these CTs with no problem. Okay.
2 amps on secondary, and I always just like to check this screen, make sure everything's hooked up right. You know, you can see the rotation right here. We're looking at ABC, so that all looks good. So we'll go ahead and stop this.
Well, can you go back real quick? One thing I want to note is the way that Brylan did this is great in that there was a difference why he hit the vector button right here so that he could take a look at it before he went into a test, because if he goes into a test, once he goes into a test, being able to toggle back between your primary and secondary current is not available. So he's just gotten in the habit of using that hotkey on the side of it to take a look at it first, because like I said, you can see down here where you can toggle and look at your primary current if you wanted to. We're not on the primary current right now with our high volt probe to be able to see it, but it's just a good general, once we keep saying this, good practices, good general practices, and he's done enough of this. He wants to take a look first before he goes into the test and take a look at those vectors, because they can also show you something drastic. You might want to go, whoa, let me look. Maybe I've got something connected wrong, or maybe there's something. This will show you something that could be, you know, a very apparent but pretty serious problem there. But right now, we're seeing what we would typically want to see in a Y connection. We're seeing three separate. We got A, B, and C, red, yellow, blue. We're always red, yellow, blue on our stuff. So you're just seeing that we've got three distinct phases here, which would be indicative of a Y connection. And you can see here we've got separate. So we've got a Y connection. All that looks okay, but remember, toggling between the primary and the secondary current is big there because it shows me two different distinct problems with my CTs, okay? If I were to look initially, and when I turn the test kit on, I'm on secondary. I'm looking at the secondary side. So when I'm turning the test kit on, I'm looking at all the secondary. Let's say I saw polarity reversal on A phase. Okay, I looked on A phase and I got something like this. There was my A phase current. And there was my A phase voltage. If I had something, if they were way out, like 180 degrees out on this, I would say, uh-oh, it's showing me right now polarity reversal on the secondary side of A phase. That's what it's showing me. But what could the problem actually be? This is just showing me secondary. If I toggle and hit that primary button, one of two things is going to happen. If I hit the primary button and it shows them, boom, over here, right? It shows my A phase current over here, and the two of them are tied together, then the polarity reversal only exists on the secondary side, which means the two wires here have gotten swapped on my CT. Okay, that means that is a swapped wire. 99.9, it's going to be a swapped wire right there, right? And that means that the problem is just on the secondary side. It's not on the primary where these conductors are going through with the CT. The problem is purely on the primary, because when I toggled between those two vectors, it showed secondary polarity reversal, it showed primary, they were in line with one another, and there wasn't polarity reversal. So then that means my number one culprit right now is the two wires being swapped on the secondary side of my CT. If, however, if I saw this on the secondary side, which is what it's showing me when I turn the kit on, and then I toggle and I hit that button to show primary current, and it shows the primary current just like this too, then that means my problem is on the primary, because the secondary always follows the primary. Whatever the primary does, the secondary is going to show. So if I have polarity reversal on the primary, then the secondary is also going to show it. But what is that? That's the whole CT being in backwards, okay? Because it has to affect the primary flow, not the secondary coming off my two secondary tabs. The primary flow is backwards, okay? So I've either had to run the conductor in backwards, which I didn't because the conductor is just going down the pole. When I put this CT in, I didn't put the dot side in towards the pot, and I've got it in backwards. Two different problems. One, it might be the guys there at the utility company, the meter techs, can swap the wires out on the secondary side, but they can't the primary side. So it could be whole different crews, whole different work orders, whole different outages now are involved, whereas, no longer outages, whereas now I'm just swapping that CT right there, right? I'm just swapping the wires on the CT. I don't have to get an outage and turn that CT around the other way, all right? Remember, you can see all that pre-test. Once you go into the test, you can't toggle to look at the primary current. Okay. Separate currents on all of these and separate voltages, which is also indicative of a Y. We don't have any ABs or BCs. It's A, B, and C all separate. So he did hit that just to make sure. He took a look to make sure there was nothing here. If you had three flexes on there already, he could toggle between primary and secondary and maybe see something on there that on the primary side that he would need to take a look at. So it's just good general practices. Great point. You got to be able to see the primary to look at it, right? So when you're doing an overhead, it's kind of difficult because you have to have it up on that primary to be able to see it to toggle and take a look, right? But if you got three flexes on there, you can toggle and look at all three phases at the same time. If you have the primary just up on A phase, you can toggle and it'll show you the primary on A phase, but you got to be able to read it, okay? So you got to have something up on there reading the primary to do a comparison, okay? and getting in good habits, okay?
Another thing I'll do when I'm out in the field testing for utility companies, if there's not enough load on the site, you know, I want proof to show the guys, you know, if whoever I'm working for comes back and says, well, that site should have had enough load on it. Why'd you have to run a phantom load test? Why couldn't you test my CT? We'll say, you can come over here, and on this vector screen, you can hit the F6 button, which stops the screen and saves it where it's at. And then you can come over here to F1 and hit save. And it will take a screenshot of that right there and record it to this site. So you can go back and pull it up and show them, be like, look, on this site right here, you just had 0.2 tenths of an amp on A phase or B phase, you know, all the way through. And that just saves me, you know, from having to try to explain myself, be like, man, this site didn't have any load on it. When I can pull this screen up right here and show them, be like, man, right here's what I was looking at. You know.
That's a great point. And we've mentioned it in the webinars, but now you're getting to see it out in the field, just what Brylan's saying. You can take any of these hot buttons right here, you can press them to look at something you might see to be either a trouble spot or just what Brylan's saying to give you proof of what you found out in the field when you're trying to show somebody in the office, is that you can always stop them and save them, and they will be added to the reports, okay? So you can put the waveforms on there, you can put the vectors on there, you can put that RMS table showing all of the different quantities in there, or you can actually show the harmonics in graph form. You can capture any of those, and you can hit stop and save, and you could add that to the report. It'll be a separate PDF page on the Meter Site Manager report, or you could actually do it on, you know, there's different ways you can get the data to somebody, but always try and capture any of those problems if you can pre-test, because once you get into the test, you know, it's a little bit harder to hit your buttons and stuff. So I'd go ahead and look at it. It's when we talk about setting up the equipment, it's kind of like that way when you get to a site. There's some pre-work that needs to be done before you really get into the test, okay? And it gives you a better assessment of the site before you actually get into the test. Because most equipment, once you get into the test, it's set up that way. It's going to go bing, bing, bing. But this way, you can start in the beginning, do a little bit of troubleshooting and look at some things you might want to note to explain to them later. Or if you're wanting to report back to folks in the office what happened, it's better to have it on paper and it to show somebody. That's a good point. Good point. And I will make a note that, and we talk about this all the time, what would you have said about the power factors on this site? Just looking at those angles that we had on all three phases.
I'd say that's, you know,
not too good.
No, not
if
good.
You noticed on the vectors when Brylan was looking at the vectors, those angles are pretty wide on all three phases. So I would say from over here, yeah, if you look at them, well, I'm thinking those probably aren't great numbers, right?
No, they're not.
So there's something going on with either some big time motors.
And we always say that you can look right here. We saw the size of these angles right here, and then right here to the right, it's showing you the corresponding numbers. So we're seeing power factors of 0.755, 0.696, 0.776. That wouldn't be the most optimal that you could get. So that's telling you there's obviously some stuff going on the other side of the wall where you can hear all that noise that's going on, right? I know that this was I think this is a pipe fab shop is what it was, this 9S site. It had been a pipe fab shop in the back. Now I believe it was cutting a lot of granite and stuff. So it's cutting granite tops. It's doing a lot of granite work. So it's those saws going, and I imagine they got controllers on the saws and all that's adding stuff to it. But I imagine it's a lot of motor load. So what we're seeing here is a lot of inductance, which makes the angles bigger. A lot of VARs. So that's what's going on here.
And load shift, there's something going on in there that we don't have too good. I would guess probably a lot of motor load, wouldn't you? A lot of inductance.
Oh yeah, and you can hear it in the background cutting in and out.
A lot of inductance going on there, so it's just a note, and we say that all the time. The bigger the angle, the worse the power factor, and you saw it right there, all three of them. So we know this is probably just mainly motor load what's going on here. So, and when you add all the inductance to it, then it starts adding and growing that angle there, which is worse power factor, and which means that we're making less money, right? So, okay.
We've got our pulses here. You just seen on the screen right there, our pulse come through.
So it came out, the test came out okay. One thing to note on here is, note the VARs on here, because remember we talked about all that, we talked about the inductance and we were talking about those angles and that. So when you have those wider angles and you have more, and you have a worse power factor, you have more VARs involved, right? Remember on any of these webinars or any of these classes, if you've seen in any of the meter schools, you've heard Steve Hudson with us talk about it's the foam on the head of the root beer, right? It's the part of it you can't use. So obviously we're going to have a little bit of some VARs here involved, because remember we had those big angles. So we had a worse, if you will, power factor, which is a smaller number, because when you multiply by a smaller number, you end up with a smaller number. So when we multiply by those smaller numbers, our watts end up smaller. So it does affect us as a utility company. So we noticed that our VARs are pretty good there, and we would expect them to be large because we're seeing those big angles. So with those larger angles, there are more VARs involved. So it's just another thing to note on the screen that I wanted to show y'all.
So we're at the point now where we're getting ready to test the CTs, and we're going to finish out the testing on this site. And right now, remember, we're trying to keep these Rolodexes in our head. So right now we're saying, okay, I've liked the secondary current that I've seen. Looks like it's going to be okay to test those CTs. I'm not less than 0.5 ohms. So I think I'm going to have enough load to test there and get a decent test on those CTs. So I don't think I'm going to have any issues there. It's going to be overhead, so I'm going to need to use my high volt probe. So remember, I'm just going to do one phase at a time, and I'm going to move it. I would expect to see, once again, I've seen that the number of VARs and everything going on there, so I've kind of noted that. And if anybody asks, I can always say, you know, well, there's a lot of VARs going on there because of motor load. Typically, is what it's going to be, and you got a lot of motors in there cutting that stuff, cutting the granite and doing all that stuff, and they got controllers on them clearly. So we kind of know what we're getting into moving forward, which is going to be, we know that we don't have great power factor at the site, but we do know that, that at least we're going to have a good load so we can get through the test okay. So that's the next thing. We're going to use the overhead probe and go up top and get the primary current off those CTs up top. So we took a look. We didn't see any kind of polarity reversal. We just noted the bigger angles, which we didn't like because that meant a smaller power factor to multiply by. The assessment of the site, a little washout, arcing behind the can, but all those things would be noted. And so far it looks like we're going to get through the site. So far so good. We'll get through it and we'll get a good test on the CTs because we don't have to keep fighting a very low secondary current on there. So it looks like we've got enough load for that. So we really appreciate today. This next week, JP and I are going to go ahead and film one for then because I'll be up in the Northeast. Those boys up there will be trying to understand me up in Massachusetts. So anyway, look forward to coming back live with you guys the next week after that and us doing this again. But once again, thank you so much for your time. Thank you so much for your attention on this, and we sure hope you're getting something good out of it because we've really felt blessed to be able to do it. So thank y'all. Be safe out there, all right? Have a great day.